Yeah, hi. So we will be starting with manual memory management. So if we know what is the pain point, then it will be better that okay, what things changed in rest. So it will be easier to understand okay what things changed from previous to newer version the programming language. So let's suppose we have right now a code with us. Like this is pseudo code. So we have a main function and as we know the compilation starts from main function. So here integer a is there. Okay, first I will define that there is a stack and heap. Okay, these are the two terms you must have heard of. So what are these? So stack, so stack is the memory, whenever a variable is there, so memory is allocated in stack if the size of that variable is known. And if why if that size is not known, so that is allocated in heap. Now the thing is why there is a partiality that okay if size is known we are saving this in stack and we are not saving it in heap. So in stack in the runtime its size can't be increased, so we are keeping the things which like whose size is known, like say function main is here, so the function main will come that okay we are executing the main function, so it will come, then it says okay okay we should make like a box so it will be more uh, it will make more sense. Now let's say we have a main function. Now see, we have an integer a. Now we know that okay this will have a like the size is 6. So okay, here we will allocate a equals 2. Currently the pointer was here, the compilation that another compiler is running from this like currently it is on this line. Now it will go to this line calling the stack only function. So where is that stack only function? It will look for, and it will find that okay here we have a stack only function. It asks for an argument which is b, and we are giving it like 2 from here. So it currently the b is 2. Okay, now this stack only will come here. Memory like the function will come as stack only, and the parameter will be defined as b equals to 12, then c equals to 3. Then again one call is happening, stack and heap. Okay, now this will come into the context that okay this needs to be executed. Now you can see that I am stacking the functions on each, stacking the functions. Why this is happening? Because the function call is not completed yet. If you see, like okay the we have completed if this line was not there, this function should have completed, so it could be removed from here because the comparison is complete. But currently we have called this function and this function called this function, so we have to execute, we have to go to the tail of the end and then we have to go back. So currently stack and heap function was called, and here we have d which is equals to 5 and e. Oh, here e I was allocating e here, but see here it says allocate integer 7. So this is allocating a memory, so this will be allocated here. Or if say there is a string that says sign, so if there is a memory allocation for a string, that also needs to be allocated here, because we are not sure, okay, if it can be increased or decreased. So we are not sure that, okay, this string is fixed. Yeah, although if it is a fixed size, or we can have it, but this is not a fixed size. So we have a pointer here. See, here we have integer, 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 or something like float or char, but here we are having a pointer. So E is having an address of this variable. What happens here, a block is looked for. Why I said, because in the heap memory is not organized. So if you see, like here it is empty, here there is a location, maybe here is allocated, and here is empty. So let's say that these things are empty. So if you see your hard drive, if you are like a window user, you will see there is a bar says C drive, and this much is full and this much is empty. So this doesn't mean that, okay, your hard disk is occupying this much space only and these are left. So it is not organized. It might be somewhere that this and this and this, and it is not organized. So similarly, this program needs to search for a place where 7 can be accommodated. So let's say this is like the program found a place, and we got a like a location where we can put 7, and its address is OXF something something. So this address will go inside E, OXF something something. So now here we will have that address. Okay, so currently whatever the like having a more like currently we do not have a size of this 7. It could be greater, or like the size can be increased or decreased. However, it is integer, it will not happen, but this is written as allocate. So let's say, suppose, okay, if there was something string s equals to high, now these needs to be allocated in heap. Okay, I hope this is clear that, okay, for fixed size of like values for a variable are stored in stack, and those things which are having like whose size can be increased or decreased, or these things are allocated in heap. Or if we manually allocate, it will be kept in heap. Till here there is no problem, all good. But the problem comes when we see there is no line written here which says deallocate integer 7. So we are not deallocating this 7. Now what happens? Okay, now let's suppose all things like goes away. Okay, and you have only 7, like 7 here. Now their memory and some things is there. Now this program ended and we have 7 here, which is not being used. It is just useless, kept here. Now let's say again this was ran, and again 1 7 was there, again 1 7 was there. Now this way it will lead to a memory leak. Okay, now here is a new concept. So like C was having a deallocate, and other things like Node had a garbage collector, Java had a garbage collector. So what is a garbage collector? If might be case, let's revise. Garbage collector. Okay, so garbage collector has a job that it checks whenever like the function ends, it checks that if there is some memory which is having some value but there is no reference to it. So let's say there is a value in heap which is having 7, which is having 66 as string, and there was a variable e which has a something reference to this. But garbage collector sees that okay, this allocated memory address is not referenced by any variable, so this needs to be clear, so it clears this value. So it takes time in the background, so that's why for better Rust remove that. Garbage collector is not present in Rust. So the point is how Rust handles that. So there is a smart pointer. Smart pointer is like a wrapper on normal pointer, and it just deallocates the memory which is put out of scope. So this is if you use a smart pointer, it's just a wrapper over the 7. It just goes and deallocate automatically. Okay, more in next video. Thank you.